flight.
Nestled against the Apollo command module. On launch of the Saturn V rocket, there were a total of 9 arms. In addition to providing access to the spacecraft, they connected propellers, electrical, pneumatic, and instrumentation ground supply lines to the stages of the Saturn rocket and the Apollo spacecraft. They also provided access for technicians to the interior of the rocket and spacecraft for minor repairs and adjustments. During the last moments of countdown, just before liftoff, all 9 arms were on their position.
That's a smaller rocket. No, it doesn't go.
What's going to happen to our astronauts without gravity? That was the big question in 1960, since no one before had broken the bonds of Earth. Here, some of America's first 7 astronauts get the feel of zero gravity aboard a C-131 at 18,000 feet. Back on the ground, the civil rights movement is gathering momentum under the direction of Martin Luther King. President Eisenhower signed the Civil Rights Act of 1960, just a few months before making commitment.
This arm actually used by the Apollo astronauts when they went to the moon. Gallery of Spaceflight. Connecting the history of our exploration of the world beyond atmosphere and gravity. Mercury.
We'd like to have you come visit too, but in case you don't have time, we brought little of the refuge to you. Must be feeding time for our bald eagle. Go on in and visit them to my right. He's a really remarkable creature, including our national symbol. Off you go now.
Good morning, folks, and welcome to the Kennedy Space Center. My name is Steve Gaudio, and I'll be your escort for your tour. No smoking on the bus, please. Windows must remain closed and photographs.
inside, even though, again, you've got this helmet down, it isolates you for all intents and purposes from any outside noise. The sound, the shock, and everything from the solid rocket boosters is so massive that you hear it, you feel it, and the vehicle just kind of starts to vibrate.
Pad 39A, and that was the launch site for all but one of the Apollo moon launches. And it was the launch site for the first 24 launches of the space shuttle. Launch pad 39B, which is further off to your left, was the launch site for Apollo number 10, the manned Skylab program launches, the Apollo Soyuz test launch.
No filmó.
V is in Victor, T is in Tom, 2442, I'm Victor. All the way up out of spacecraft, let's return to our bus, please.
Öppna vatten.
We have already taken the first small steps outside our planet. We designed this shuttlecraft to carry people and cargo up into orbit. Here, far above the Earth's atmosphere, we're learning how to live and work in space.
You got to go to the order.
The exterior shows just a little of the expected wear and tear of many trips back and forth. The shuttle is equipped with a robotic arm to move large payloads carried up from Earth.
Houston, do we have a go for Spa's maneuver to release that?
It has lifted from the cargo bay a spacecraft which carries a German telescope named Orpheus and a remotely operated IMAX camera. Through its lens, we're seeing as never before the exterior of the shuttle as it orbits the Earth. As the ship spins around, anyone inside feels an outward or centrifugal force that acts like gravity. In another design, parts of the ship spin around a stationary hub. But the rotation of a small spacecraft could make the occupants disoriented or sick. We could avoid this if we built a spacecraft large enough and with a slower spin. But it would have to be about as long as the Golden Gate Bridge. How could we build such a large ship in space? To get to Mars, for instance, we might design a spacecraft with two modules, one attached to each end of a very long cable or tether. Once underway, the tether would be extended to separate the two modules. The whole assembly, rotating about once per minute, could provide the synthetic gravity needed. But until recently, tethers were merely an elegant idea. The concept would have to be tested.
So far, we have good satellite stability.
So an experiment was flown on the space shuttle. An Italian satellite was deployed on a very long tether. Today, Mars is a frozen world. The average temperature here is lower than at the Earth's South Pole. But long ago, when water may have flowed here, it must have been warmer. We don't know why Mars turns so cold, but perhaps it could be made to change once again. Could future generations somehow transform Mars into an... Cape of Good Hope beneath it, the space telescope is now poised to begin a new era of exploration. One of the astonishing discoveries is a first close look at an enormous and very unstable star we call Eta Carinae, 4 million times more luminous than our sun. Its last outburst was seen in 1841, and now Hubble reveals that it has blown 2 massive clouds into space. The clouds contain the heavy elements essential for the creation of life. Now, in the heart of the Orion Nebula, Hubble reveals a stellar nursery. Gas and dust are condensing here to create new stars. And even more astounding, new planets are being born. Never before seen, the dark material appears to be a new solar system forming around a young sun. Hubble has now provided evidence that planets are common in the universe. Life may be widespread among them. Perhaps we will hear a signal. Our curiosity and our need to progress compel us to move outward, to explore the worlds of our solar system, our galaxy, and the universe beyond. The distances are vast, the voyage hazardous, the destination daunting. Still, we choose to explore. What we discover will shape our destiny in space.
Will you please think what's happening in each one?
Eles dormem aqui, é? Ué, os caras vão ficar doendo, né?
Welcome aboard. You are a Spatial Explorer. Exactly below the commander and pilot work area. This has been approved life and experiments. To the left of these rockers is the galley. And remain open while the vehicle is in orbit. The mirrored surface of these doors.
Dois lá, né? Não sai voando.
The large payload bay area.
Yeah. We could also. No painel.
You are now standing on the flight deck of the Space Shuttle Explorer. Explorer is a full-scale model of Space Shuttle Orbiter. This exhibit, like each of NASA's full operational Space Shuttle vehicles, is 122 feet long, over 56 feet high, and has a wingspan of 78 feet. Explorer is equipped with payloads are attached to only the slightly defined
Vai lá. Não, não. Vai você. Móc. Mua vậy đó, không biết rồi.
Possible here on Earth. We're now returning to space in a variety of craft. We call this Mission to Planet Earth. Here we can see it as a whole.
Sei lá, Índia. Índia? Sei lá, Índia. Onde foi ainda a gente foi? É mesmo. Exatamente onde a gente foi.
Sri Lanka,
Sri Lanka.
India. But now we also see a planet bathed in the light of nearby
pertinho. Índia.
Ours is a world of constant change, shaped and reshaped by nature's powerful forces. Its blueness came out of the earth itself. The ancient oceans were steamed out of the interior by erupting volcanoes. this one as the Big Island of Hawaii. Now, whole continents appear. Europe is on the left, stretching beyond Gibraltar to the horizon. Mediterranean Sea. On the right, Africa. Deep in the heart of Africa, we come upon a land of forests, lakes, and rivers. We're crossing over Lake Victoria and the broad plain of the Serengeti. Here beneath us, our planet's systems of water, earth, and air interact to sustain life. To observe this complex environment more closely, we'll drop down to the surface of the strange red lake below. This is Lake Natron. It's hard to believe any life could exist here. But in fact, the lurid color is the life itself. The water is teeming with red algae that feed on white soda from nearby volcanoes. Ash spewing from somewhat like a miniature Earth. The environment is carefully balanced to keep the astronauts comfortable. One system controls the temperature. Another supplies oxygen. On Earth, the forests and oceans absorb the carbon dioxide we exhale. In space, the crew uses special canisters to clean the air. For a short time, this artificial system supplies to the astronauts what the Earth has always provided for us. Its natural systems slowly recycle the air, the water, and even the rock. In one cycle, heat from the sun evaporates water from the ocean to form clouds. Winds drive the clouds over land. Rain from the clouds falls back to the earth and then runs down to the sea, where the cycle begins once more. Heat stored in the clouds can drop upwards into towering thunderheads. Inside them, powerful electric